Hello and welcome to spss 4 from part S8. Now we're going to look at whether whether there is a difference in the level of nutrition between firms in the same two categories, ecotourism and standard firms. So we can do that quite quickly just by using this button, which brings back previous commands. So bring back the previous explore command. So we still want to split it by eco license. Annoyingly, it's lost the... Oh yes, that's fine. And whole price, instead of whole price, we want to do nutrition. I was thinking of the t-test. So to swap out whole price, put in nutrition. Everything else can stay the same. So you get the same plots. And so we have it. So mean nutrition in standard license area, 2,060 calories per person per day. Ecotourism lower, 1,712 per person per day. And the median is also, gosh, the median is very similar there. The median is also lower. Okay. Interesting. So it could be that ecotourism is happening in areas where people are poor for other reasons. We're going to be the net effect of that. They don't get so much money. We'll see. We won't see, but because we won't be able to conclude. But those are two possibilities. Now, after doing that, what's the point of doing a test? Why should we want to do a test? Because we can already see that the levels of ecotourism on average are lower than standard license on average for nutrition. Well, again, this only applies to the sample of 60 firms. We are interested in the whole population of 880 firms and possibly beyond that. So we're looking for external validity. So to find out whether these results have got external validity, whether they hold beyond the sample, we do a t-test, which is what we'll do next, hopefully. So write down suitable null and alternative hypotheses for the test. Now, two things. When you write down null and alternative hypotheses for the test, you shouldn't be lazy. You should write them accurately and completely. On the other hand, there are some arguments in favour of laziness, which is that if you've already written one thing out exactly, why would you do it again? So it's also a good idea to kind of keep things comparable. So if I just grab those two that we've had before, insert them down here, paste that in there, and just change mean price nutrition. So the mean nutrition in areas where ecotourism firms operate and I think, what's the definition there? Yeah, so it's during you could put, because there's also nutrition outside the holiday season. So you should put the full details in. So the mean holiday season, or let's say peak season. So the mean peak tree season nutrition in areas where ecotourism firms operate is the same as the mean peak season nutrition. So it's good when this is getting all written out neatly. And once you've done it once, though, then you can just copy that and replace that second one with it. That should now be changed to H1. I don't really want to have these labels as questions. That would be very confusing. It's not the same. So trick is to keep the two hypotheses as similar as possible, except for the thing that has to change, so it brings out the difference more sharply. And the thing that has to change is that the null is saying that mean nutrition levels in peak seasons is the same between these two groups. I just need to change the wording a bit more. And the other one is saying that the mean nutrition in peak season is different between the two groups, is not the same. It's in areas where, don't I? So make that. That's better. So it's quite a mouthful. So that'll do as null alternative hypothesis. Okay. So take the time to write things out fully and precisely. Right, do a test in SPSS and then explain what we can conclude from results. Well, the test should be easy because it's the same t-test. So you can go through analyze to compare means, independent samples t-test, or you can just use the previous commands button here, bring it back up. Same thing. This is already set up for you, so all we have to do is throw out the whole price and put it in nutrition, because this can stay the same. And then pow, comes out with some results. So here's the results. There's the mean comparison again, which we had before, so that's just in the sample, 2,000 versus 1,700. Null hypothesis says, if we assume that, in fact, in the whole population, null hypothesis is true, so in the whole population, the means are exactly the same, what's the chance of drawing our sample of 60 and finding a difference in the means as big as this one? And it would be quite low. And here you can see better what I mean by the fact it doesn't really matter which of these two lines which two rows you choose. They're 0.049, 0.043. They're both small. Strictly speaking, because this is a high number here, we'd stick with the top row. But it comes to the same thing. And to conclude, I imagine the next question must be to conclude. What can we conclude from the results? Well, if null hypothesis is true, chance of seeing this bigger difference is 0.049 is less than 0.05. So it's very small, it's less than 5%, so it's quite surprising. That makes me want to say that the null hypothesis is not so convincing, because if the null hypothesis is true, I have to believe something very unlikely happened. So I'm going to reject the null hypothesis, because the probability value, the sig value, is less than 0.05, less than 5%. And I can say, officially, I reject the null hypothesis at the 5% significance level, and instead I accept the alternative hypothesis. The alternative hypothesis is the one that says that mean peak season nutrition is different in the areas where the two different sorts of fern are operating. And what we can conclude from that is that there is some fairly strong evidence here of a difference in nutrition levels in the peak season, depending on the license the firm has to operate in that area. Okay, so I'll go on and look at some other t-tests for other variables in the next video, but for now, thanks for watching.